So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see that how to check in a certain number how many bits are present. Okay. So let's take one example. Value 39. So if I convert this number into a binary number, it will look like this: 1 0 0 1 1 1. Okay. Now here I have to count the number of set bits. So this is 1 2 3 and 4. Okay, so I have to return answer as 4. Okay, let's take one more example. 0 4. If I convert this number into binary, it will look like this: 1 0 0. Okay, so I have to return 1 because the number of set bits are only 1. Let's take one more example, that is 0. Here if I convert this, it will be 0 0 0. So I have to return 0 because no bits are set, right? So this is a problem. I hope you got this. So let's see that how we can solve this problem. But before that, let me tell you one thing, that we have started a series on DSA problem. If you know the fundamentals of DSA but getting stuck while solving the DSA problem, this series will be helpful for you. If you're preparing for interviews and placement, you can visit to this playlist. The link is in the description box. Thank you. Now, so before that, we have to learn one property and one operator. Okay, so let's learn one operator which is known as right shift operator. Okay, the symbol for right shift operator look like this. Okay, now let's take one number which is 16. The binary representation of this number is 1 0 0 0 0. Okay, now if I have to do a right shift for one time, it will look like this: 16 right shift 1. Okay, so what we have to do, we have to actually shift each bit on the right hand side by 1. Okay, so 1 will come here, 0 will come here, this 0 will come here, and this 0 will come here. Okay, and what about this 0 will simply drop off. Okay, and what will happen in this place? So here we have to simply put 0. That's it. Okay, so we have to add 0 by ourselves, and for this 0 we have to drop it off. Okay, let's take one more example. Value 39. So the binary representation of 39 is 1 0 0 and 1 1 1. Okay, so 39 right shift 1. We have to right shift the digit, right shift the bit by 1. So here I have to add 0 by myself, and this 1 will come here, this 0 will come here, this 0 will come here, this 1 will come here, this 1 will come here, and this 1 will simply drop it off. Okay, I hope you got this. Now let's see one thing. If I have value 32, okay, so the binary representation of 32 is 1 0 0 0 0 0. Okay, so this place represent 2 raised to 0, this place 2 raised to 1, this place 2 raised to 2, this place 2 raised to 3, 2 raised to 4, and 2 raised to 5. Okay, now if I do 32 right shift 1, okay, so don't you think that this one will simply come here, and other all 0 will be shifted to the right hand side as well? So 0 0 0 and 0, right? And here will be 0, right? So what will be the value of this? It will be simply 16. Why 16? We can see that, see, this 0 has been shifted on the right hand side by 1, right? So initially the value of this one was 1 into 2 raised to 5, that is 32, right? But now this one has been shifted on the right hand side, and the value of this place has become 1 into 2 raised to 4, that is 16. So if we shift the bit on the right hand side, it is actually decremented, or let's say divided by 2, right? Let's say if we do one more time, so this one will come here, this 0 will come here, this 0 will come here, this 0 will come here, and this 0 will simply drop it off, and we will add 0 in this place by ourselves, and this 0 will come here, right? I hope you know this. Now the value of this, this is a binary number. If you convert it into a decimal, it will be 8. So here also we can say that the 16 is getting divided by 2, so it becomes 8. If you do it one more time, it will be 4, then 2, then 1, then 0, right? So if we do n right shift 1, the answer we will be getting is n by 2 raised to 1. Okay, if we do n right shift by 2, the answer we will be getting will be n divided by 2 raised to 2. Okay, if we do n right shift by 4, then the answer we will be getting is n divided by 2 raised to 4, and so on. Okay, so that's it for the right shift operator. Let's know one property. Now the question is that how to know whether the last bit is 1 or not. Let's take one example, 39. So the binary representation of 39 is 1 0 0 1 1 1. Okay, and I want to know that what is the last bit, whether it is 1 or 0. Okay, here we got to know that it is 1. Okay, what we have to do, we have to simply AND it with 1, 0 0 0 0 0 1. Okay, so this decimal representation of this is 1, and this is 39. Okay, if we AND it, I will be getting 1 as the answer. So if my answer is 1, if my answer is 1, then I will get to know that the last bit is 1. Okay, let's take one more example. Here in this case, I'll take 4. Okay, so it will be 1 0 0, and if I AND it with 1, the answer will be 0 0 0. So we got to know that the answer is 0. So if the answer is 0, then the last bit is 0 of this value. Okay, so if n and 1 is equals to 1, that means the last bit is 1, else it is 0. I hope you got this. Now using these two, one operator and one property, we will able to solve this problem. Okay, so what we will be doing, we will be, let's take this example, 1 0 0 and 1 1 1. Okay, first of all we will be doing the AND with 1. Okay, so if I do AND with 1, I will be getting answer as 1. Right, here will be zeros. Okay, I will be getting answer as 1. Right, so I will get to know that the last bit is 1, so I'll simply increment the counter to 1. Right, now I will simply right shift this value by 1, so that this bit will be drop off, and in this place, in the last place, this one will appear. Okay, so let's do right shift for one time. So 0 1 0 0 1 1. Okay, I have done 39, right shift 1. Okay, now again we will be doing AND with 1. Okay, so the answer I will be getting is 1. Okay, since it is 1, I'll simply increment the counter to 2 now. Okay, that means I found this last 2 bits are 1 now. Again, I have to right shift this value by 1 time. So if I do this, I will be getting 0 0 1 0 0 1, right? Again do and with 1. So again I will be getting answer as 1. Since it is 1, increment the value to 3. That means the last 3 bits are 1. So due to that, I'm getting 3 as an answer. Okay, again do the right shift by 1. So I will be getting 0 0 0 1 double 0 and do and with 1. If I do this, here I will get answer as 0. In this case, you don't have to increment the counter. Okay, now again do right shift by 1. So it will be 0 0 0 0 1 0. Okay, do and with 1. So you will be getting answer as 0. Don't decrement the counter and do right shift by 1 again. So 0 0 0 0 0 1. Okay, and do and with 1. So you will be getting answer as 1. Simply increment the counter by 1. Okay, now again do right shift by 1. So it will be 0 0 0 0 0 and 0. Why? Because this bit will be drop off. Okay, so we will be getting 0. Now here we can see that no bits are set, right? That means no bits are 1. So we will simply come out of the loop. So the pseudo code for this will look like this. While value of n is greater than 0, then we have to do if n and 1 is equals to 1, then simply increment the counter. Okay, after that we have to right shift the n by 1. So I will be using here the shorthand operator. So n right shift equals to 1. That's it. You can replace this value, you can replace this line by n equals to n right shift 1 as well. Okay, and at last you have to return count. Okay, so you will be having the number of bits in this value, the number of set bits in this value, which is 4 now. Okay, so let's talk about this time complexity and space complexity. Here we can see that this while loop is actually running for the number of bits present here. Okay, so and how we can define that? We can see that it is actually going for n by 2. Okay, that means initially it is n, then it is n by 2, then it is n by 2 raised to 2, then n by 2 raised to 3, and so on till n by 2 raised to k. This value is similar to 1, or let's say equivalent to 1. If you solve this, the value of k is nothing but log n base 2. Okay, so the time complexity is order of log n base 2. And if we talk about the space complexity, we didn't take any extra space, so it will be 1, order of 1, that is constant. Actually, I'm not going in deep that how we are getting order of log n base 2, because I hope you know that how to solve this. But if you don't know, you can comment it down. I will be explaining it in the comment section. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.